Alright, so we have the motor hooked up into the choke with the driver coil, and we're separating the back EMF, all coming from a battery, and we're separating the back EMF and measuring what's coming out of the battery on the whole unit. So the unit is taking 0.09 amps, let's call it 100 milliamps, and the back EMF, as you see, I'm separating it. Now I'm measuring how much is going back into the battery from the back EMF. So the back EMF is producing roughly a little over half coming back than what we're sending out. As you see. So the back EMF is obviously higher voltage coming out of the motor circuit because it has enough to go back into the battery at roughly half the amperage as it takes to drive the motor. Now the motor's at a nice steady speed. Now just so you see, I'm going to unhook the collection of the back EMF. And now I'm not letting the back EMF get into the circuit, back into the battery. So as you see, the motor speeds up and it pulls amperage right now, and then the rotor goes quick and produces more back EMF, which neutralizes the coil and causes the amperage to practically stop flowing, just enough to keep the H-bridge powered, but it don't do nothing. Now when I collect the back EMF, that cycle's gonna wind down and it's gonna find its speed. Here we go, it's starting to stabilize out. And as you see, it's roughly half again, staying in a half as it gets up to speed 6 and 3, 7 and 4. The back EMF looks like it's a little more than half of the driving voltage required. And we're back up to about 100 milliamps, and a little over half of that is the back EMF.